Hi friends, here is a very elementary problem. We are given this equation 6x square minus 11x plus alpha equals 0, and what are all possible positive integral values of alpha. Then these roots of this equation are rational numbers. Very basic problem. We know for an equation like ax square plus bx plus c, roots will be rational when b square minus 4ac is a perfect square. Why? Because if we take ax square plus bx plus c, what are the roots? Minus b plus or minus under root b square minus 4ac by 2a. Okay. If this part, inside part, if b square minus 4ac is less than 0, then that means roots are complex. Okay. We will get something like 2 plus or minus 3i or whatever. We will get complex roots. Okay. Negative, under root a negative number is a complex number, not even real number. We don't even get real roots. If b square minus 4ac is equal to 0. Then what will that become? Minus b plus or minus 0 by 2a. That means minus b by 2a will plus or minus 0 we are getting. So that means both roots are same, both are equal to minus b by 2a if b square minus 4ac is equal to 0. Now b square minus 4ac is greater than 0 but not perfect square. Then what we'll get? We'll get roots like 2 plus or minus root 3. Okay, something like this. Minus b by 2a plus or minus an irrational number. So 2 plus or minus an irrational number. Rational plus or minus irrational, which is irrational only. But when b square minus 4ac is a perfect square, then we will get minus b by 2a, which is rational plus or minus another rational number. So the total will be rational number. So because square root of a perfect square, we can say that it's a rational number. So rational plus rational, to get rational plus or minus rational, we need to have b square minus 4ac to be a perfect square. So in this case, 6x square minus 11x plus alpha. What is b? Minus 11, a is 6 and c is alpha. B square minus 4ac, that is 11 square minus of 11 square minus 4 times 11 times alpha. That is this. This is equal to 121 minus 24 alpha. This has to be a perfect square. Let us input one by one. Okay, here alpha is a integral number. Alpha is an integer, that is also given. Okay. See in the question, let's look at the question. All possible positive integers, not even a normal integer. We want to see positive integers only. Okay, when for which values of this positive integer alpha we have this 121 minus 24 alpha is a perfect square. Let us take 121 minus 24, then 97 is not perfect square. For 2 also not a perfect square. For 3 it's a perfect square. For 4 also it's a perfect square. And for 5 it's a perfect square. So for 3, 4, 5, when alpha is 3, 4, 5, this determinant is a perfect square and we are getting rational roots. And when it is 6, 121 minus 24 into 6, which is definitely less than 0. So that is not possible. So only possibilities are 3, 4, 5. Okay, beyond 6, these are imaginary roots again. Okay, and less than 3, that is 1, 2, these are not rational roots. We are getting irrational roots. Okay, right, guys? These are irrational roots. So the correct answer is 3, 4, 5. When 3, 4, 5, of 3, 4, 5 values of alpha, we have rational numbers as roots. So the correct answer is D.